Hello everyone. In today's class of biomolecules, we have come to almost the closer of the chapter, that is the enzymes. Before this, we have discussed about the various kinds of biomolecules which are very important for our living organisms to survive. Before we move on to enzymes and its properties and of course the naming of the enzymes, we should know one more thing which has been dealt in your chapter is about the dynamic equilibrium. See, any living organisms in which the biomolecules are formed, sometimes these biomolecules on its pathway of formation is converted into that of the other biomolecules. So it is a constant process of formation as well as breakdown of one molecule to another, and from another molecule it combines to form one molecule. So this is a repeated process, a continuous process to maintain the steady state or the equilibrium of the living body. Now, this formation as well as breakdown is togetherly known as your metabolism. Now, metabolism is a process by which we can say, yes, the living body is active, or an organism we can call it to be living if the organism performs various kinds of metabolic activities. It's like a pathway. Some molecules are, in the verge of formation, then they diverge. That means they break down to form two more molecules. Sometimes they unite somewhere to form another molecule. So this keeps on happening. So when a molecule is formed, it is always accompanied by the utilization of energy, and this type of process of metabolism, we call it to be your anabolic processes. And there is another part of metabolism in which a larger biomolecule breaks down into smaller biomolecules, and we call this to be a catabolic process or the catabolism. So anabolism is accompanied with the utilization of energy to form a new substance or to form a new organic material, whereas catabolism is a process in which a release of energy takes place. When a chemical bond is broken, as a result of it, a huge amount of energy is released, and this energy is stored in the form of ATP in the living body to perform the other metabolic activities. So this is how the living body works, by the formation and the breakdown of the various biomolecules, and that is what is being discussed in the next one or two topics after that of your biomolecules. Now today we are going to discuss in broad aspect about enzymes. See, the enzymes have been worked upon by many scientists. It was Pasteur who worked upon, and then it was Kuhn who worked upon. So enzymes was first noticed from that of the yeast. Okay, N means inside. Enzymes word has come from that is yeast. So it was first reported from the yeast, so that is why the name enzyme has been coined. Okay, so this is how the enzyme word has been derived, that is in yeast. Okay, now what are these enzymes? Of course, when we talk about enzymes, enzymes are associated with the living body or the living organism. So as a result, we can call it to be the biocatalysts. Now, what do you mean by bio? Bio means living, so something which is related to that of the living body, and catalyst means which can enhance chemical reaction. That means which can help a chemical reaction to proceed at a faster rate compared to that of chemical reaction in which an enzyme is absent. So that is actually the role of the enzymes, that these are the biological catalysts which increases the rate of chemical reaction without getting used up. That is actually what you mean by that of the enzymes. Of course, there are some inorganic catalysts also. These inorganic catalysts also are of the same type, that means they also enhance or increase the rate of chemical reactions, but these are not biological in origin, unlike the enzymes which are biological in origin. Now, enzymes are generally proteinaceous, that means they are the derivatives of protein. They are sometimes in association with proteins. Some carbohydrates are there, sometimes in association with proteins, lipids are there. Sometimes the enzymes can be steroidal in nature, but most of the enzymes, these are actually the one which are proteinaceous in nature. Of course, with the that is your proteinaceous part of the enzyme, sometimes a non-proteinaceous part is also associated with it. We will be coming to that portion of the enzymes at the end of this chapter, but let us first see the properties of the enzymes. Now enzymes are very specific, since these are found in the living body, so they work in the condition in which there is a specific temperature, there is a specific pH, there is a specific substrate, and there is a specific kind of chemical reaction. So enzymes are very particular, they are very fixed about doing their work. Like for example, if you talk about most of the enzymes, the temperature in which the enzymes would like to work is within 40 degrees Celsius. If you give more than 40 degrees Celsius temperature to the enzymes, most of the enzymes, since are made up of proteins, and proteins we have just now in our previous classes come to know that they are made up of amino acid having the peptide linkages between them. So you give them heat, the denaturation of the protein takes place. That means the protein which works as an enzyme in its tertiary structure or in its quaternary structure fails to do so if you increase the temperature more than 40 degrees Celsius, because the breaking of the bond between that of carbon and sulfur, between carbon, between carbon and hydrogen, it breaks and it forms a from complex it forms a simplified structure, and when it comes to the primary structure of the protein, then it loses the property of its enzymatic action, so it becomes denatured. But there are certain enzymes which are very comfortable to work at high temperature. These are found in certain group of bacteria. We call them as thermoacidophiles. They can work even at a temperature of 80 to 90 degrees Celsius, but of course they are less in number. They are found in thermal vents, and most of the enzymes other than these, they prefer to work within a temperature of 40 degrees Celsius. So they are very specific about their temperature. The temperature ranges between that of the 40 degrees Celsius. Of course, some exceptions are there. As I told you, there are a certain group of bacteria which are called as your thermoacidophiles, which can work at 80 to 90 degrees Celsius. The next point which is discussed is it works at a specific pH. Like the specific temperature, they also work at a specific pH. Now, what do you mean by this specific pH? Most of the enzymes are very active within a pH of 6.5 to 7.5, or you can say 6 to 7.5. This is the, you can say, the ideal or the optimum pH. Optimum means the pH which is ideal for most of the enzymes to work upon. But exceptions are there, as for example, you have already learnt in your class 10 about the enzyme which is called pepsin, which is found in our stomach. Now this pepsin would love to work at an acidic pH, that means which is just 1.5 to 2 pH, because there is HCl is secreted in our stomach, so the pepsin is only active in the acidic pH and it can work over there. That means breakdown of protein can take place at a pH which is low, which is acidic. Similarly, if you talk about trypsin, which is found in the small intestine, it would like to work in an alkaline atmosphere, 8, okay, or 8.2, 8.8. So that is the pH of this trypsin enzyme which it prefers to work with. But other than these exceptions, most of the enzymes would like to work within a pH range of 6 to 7.5. The next point which is discussed is they are specific about a chemical reaction. That means when a chemical reaction is happening, the enzymes which will be working as as an oxidase enzyme, we will be coming to the naming of the enzymes, oxidase enzyme or reductase enzyme or ligase enzyme. They will not be lyase enzyme or hydrolase enzyme. They would not be able to work in an alternative form. One which can work in the form of lyase cannot work in the form of hydrolase. So they are very specific about the chemical reactions in which they are working with. So enzymes are very specific. Then next is that enzymes actions are inhibited in the presence of certain substances called as your inhibitors. Now this also has been dealt in your NCERT in a short form, that is, inhibitors are the substances which resembles with that of the substrates, and they compete with that of the substrate to the active site of the enzymes. Now what do you mean by the active site of the enzymes? We just now have discussed that the enzymes are formed of, most of them are formed of proteins, and proteins are formed of that of your amino acids. Now these amino acids, when from the primary structure, they form further inter bonding among themselves, and they form the secondary or the tertiary structure. Then they finally produces a kind of, you can say, a groove. Okay, so they form a kind of groove. Now when they form a kind of groove, so this groove will be called as your active site of the enzymes. Similarly, there will be the substrates. There will be the substrates who will be, having a site which can come and bind with that of the active site of the enzyme. So when it comes and binds with that of the active site of the enzyme, they form the enzyme substrate complex. And when such complex formation takes place, as a result of it, there is a change in the bonding between that of the that is the substrate, and as a result of it, a new compound is formed, and this new compound we call it as your product. Once the product is formed, now the product detaches from that of the enzyme, and this active site of the enzyme is again free to bind with a new substrate to form another enzyme substrate complex, and the same chemical process will keep on happening. Now the problem is that when the chemical reaction is only having the substrate, then there is no problem. There will be enzyme substrate complex, there will be formation of product, enzyme will be released, again new substrate will come and bind with the enzyme. So this will keep on happening. Okay, but if along with that of the substrate there are certain other substances which are called inhibitors. Now what are these inhibitors? The inhibitors also have this kind of site which can recognize the active site of the enzyme, and it can compete with that of the substrate, and now there will be a competition. We call it as your competitive inhibition between that of the substrate and that of your inhibitor for achieving this active site. If by chance the inhibitor comes and binds to the active site of the enzyme, then the substrate cannot find that active site, and as a result the rate of chemical reaction is reduced or is lowered. So that is a problem, and since there is a competition, so we call this type of inhibition to be the competitive inhibition. Of course there is non-competitive inhibition also. Now non-competitive inhibition, what happens is that the inhibitor in this case does not comes and competes for this active site of the enzyme. So okay, let us write it with E. E represents the enzyme and S represents the substrate. Okay, now in this case what will happen is that this enzyme, other than this active site, will have second structure. Okay, now the second structure will be in such a manner that if here the inhibitor will come and it will bind with that of the enzyme, not in the active site but some other site, then there will be a conformational change in this active site of the enzyme, and as a result of it, now the substrate cannot come and bind with that of the enzyme. See, this is a lock and key mechanism which was proposed by a scientist. His name was called as your Fischer. Now Fischer proposed that enzyme substrate complex which is formed is actually like that of a lock and key. Every lock has a specific key, but once the inhibitor comes and binds with that of the other site other than the active site, the active site's conformation changes. So if it changes, now the key, which is the substrate, cannot fit into this conformational change site of the enzyme, and as a result there is no chemical reaction and no product formation. So this is called as your uncompetitive or non-competitive inhibition. Here the inhibitor is not competing for the same site with that of the substrate, but it is binding with some other site and changing the conformation of the enzyme, and as a result the product formation is hindered. So this is about your enzyme actions inhibited in presence of certain substances called the inhibitors. Okay, and next one point which was left out in between, that they are specific about the substrates. That means a particular enzyme will work upon a particular substrate. There is a lock and key mechanism which is proposed by a scientist, that is, his name was Fisher. He said that every specific enzyme can only work upon a specific substrate like that of a lock and key, and once the substrate comes in the close proximity of the active sites of the enzymes, in that case the bonding between the enzyme and the substrate takes place, leading to the enzyme substrate complex, and then there is alteration in the bonding or breakage of bonding within the substrate, leading to formation of a new compound which is a product, and thus the enzyme is helping to convert the substrate into a product. Okay, now the example of a specific enzyme working upon a specific substrate, like for example maltase. Now maltase, from the name itself you can understand that this enzyme is capable of breaking down the bond between the two glucose units which are joined together to form maltose. Maltose is formed as a result of combination of two alpha glucose, and as a result of it maltose is formed. Now when maltase enzyme is there, then it will be hydrolyzing maltose into simple or into simplified glucose. Similarly, if you talk about about your amylase. Amylase will be working upon the starch to break it into simple compounds, that is the glucose. So enzymes are very specific about the substrate, and the names of the enzymes are also somewhat associated with that of the substrate, like I told you, as your maltase, sucrase, okay, lipase means which will be breaking down the lipids. Okay, so that is the fourth point's description, that is they are very specific about the substrates. Although there are many more properties, but here we are working upon the 5 properties which we have just now discussed. And if you go through your NCERT, you will find these kind of 5 properties only, which is dealt in elaborate manner compared to that of the other properties. Now, along with these properties of the enzymes which we are discussing, in your NCERT book you will find that there is somewhat a graph like this, in which it is being said about the chemical reaction. The rate of chemical reaction is indicated in terms of formation of product per unit time. Now any substrate, to change it into the product, it requires a minimum energy to start up. That means the molecule of the substrates, the mole of the substrates, to change it into product form, it needs a initiation energy. Once this initiation energy is achieved, then the rate of chemical reaction spontaneously starts, and the production of the products takes place at a very fast rate or at a very vigorous rate. Now this energy which the substrates require to start up this chemical reaction or to increase the rate of chemical reaction, this energy is known as your activation energy. Okay, now the activation energy, it has been noticed by the 2 scientists Michaelis and Menton, that is the substrate, in the absence of enzyme, see here it is written no enzyme. In the absence of enzyme, the activation energy requirement for the substrate to change it into that of the product is much more higher. That means it will take a lot of time for achieving that activation energy, and then only the chemical reaction will speed up. Okay, but if the same chemical reaction is provided with that of the enzyme, see the smaller one, the smaller curve is associated with enzyme, and the bigger one is no enzyme. So when the enzyme is added to such a chemical reaction, it lowers the activation energy. Once it lowers the activation energy, the rate of chemical reaction proceeds at a very faster rate. So this is how we can say that the rate of chemical reaction increases in the presence of enzymes compared to that of in the absence of enzymes. And this was proposed by that of Michaelis and Menton. And they also said that the velocity of any chemical reaction will be increasing. Okay, up to how much time it will be increasing? Of course, initially it will increase at a very faster rate, but once if you concentration of the substrates, if you keep on increasing, then a time will come when there will be the production of the that is the products as a result of the chemical reaction will not be increased by the increase in the rate of substrate addition to the chemical reaction. Now why does it happens? The reason is because number of enzymes are limited, but you are increasing the concentration of substrate, so enzymes are packed up. All the enzymes, the active site of the enzymes are taken up by the substrates. So the remaining substrates are unable to bind with that of the free enzymes. As a result, it slows down the rate of chemical reaction. So the velocity which is reached in a chemical reaction to its utmost, okay, that is the maximum velocity, we call it to be the Vmax, okay, Vmax. But there is the determination of chemical reaction is actually determined by the rate of chemical reaction reaching its half the velocity, that means half of Vmax. So the half of Vmax is actually the Michaelis-Menten constant, and we represent it with that of your Km, okay. K is a constant and M represents the Michaelis-Menten constant. It is what? Vmax by 2. Half of the that means the time period taken for the substrates to change into products in a chemical reaction on its half the way. Half means half of the that is chemical reaction, half of the substrate changing into that of the products is taking place in a chemical reaction. That level will be called as your Michaelis-Menten constant, that is Vmax by 2. We can calculate in that way. Okay, so this is about your activation energy and that of your explanation that what will happen in presence of your enzymes in case of a chemical reaction and what will happen if there is no enzymes in a chemical reaction. The next thing which has been discussed in your book is about classification and nomenclature of enzymes. Now it is given by your IUB, International Union of Biochemists. They said that all the enzymes which are existing, we can broadly classify them into your 6 classes. And these 6 classes can be further divided into that of your subclasses. But in your book, it has been only dealt with that of the classes. So we are discussing about the classes. What do the name or why this name has been given? See, any kind of you will find the name of the enzymes, it always ends with that of ASE, okay, ASE, okay, ligase, lipase, okay. So most of the enzymes end up with the name of that of your ASE. Now what does it mean? By only reading the name only you can understand that what category or what class of the enzymes it belongs to. That means what type of work it is doing, because of which the name has been given or assigned to it. The first is called oxidoreductase. That means this type of enzymes can perform the oxidation and reduction process. They are also known as your dehydrogenase, that is removal of hydrogen. So removal of hydrogen, oxidation, and which it will be adding to, that will be the reduction. So oxidoreductase or dehydrogenase, that is removal of hydrogen or oxidation and reduction. So from this only we can understand that which category of enzymes these are and what is their actually principal work. Okay, the next class of the enzymes are the transferases. Now transferases are the one which can transfer one functional group from one substrate to another substrate. That is the function of that of your transferases. It can transfer a group from one substrate to that of the other substrate. Next is hydrolase. Hydrolase means from this word only you can identify that it hydrolyzes. This group of enzymes will cause the hydrolysis of the covalent bonds, and that means with the introduction of water, the breaking of the covalent bond takes place, resulting into the formation of a new product or a new compound. So that is the work of the hydrolases. Okay, like for example the digestive enzymes in our digestive tract, like that of your amylase. The next category, lyase. Now what is the difference between that of the lyase and the hydrolase is that lyase also helps in the breakage of the covalent bond, but here it does not involve the process of hydrolysis. But here in case of hydrolases, breakage of the covalent bond takes place, removal of that is a group group takes place with the introduction of water in case of hydrolysis, but in case of your lyases, what happens is that here also the breakdown of the covalent bond takes place, but without the involvement of water. That means no hydrolysis takes place. Example of lyase is that of your aldolase, and the example of hydrolase, as I told you, various digestive enzymes are there. The best example is that of your amylase. The next one is called isomerases. Now isomers are what? That means there will be a change in the structure, or there may be change in the molecular formula. So that will be called as your isomerases. Okay. Next is your ligases. Now ligase means joining. When two small molecules or small compounds are joined together by some bonding, we call it to that of your ligases. So this is the 6 classes of the enzymes which has been classified by IUB, that is International Union of Biochemists, and which we have discussed, that is depending upon what kind of reaction they work upon, we can identify that what is the thing, or what a thing they are associated with. So this is all about your enzymes, their properties, and the classification and nomenclature of enzymes. Now the last topic which has been discussed in your book about that of the enzyme chapter is that of your cofactors. Now what are these cofactors? Now cofactors are, we all know that enzymes are made up of proteins. Now there are sometimes non-protein part also which is associated with that of the protein. Now the protein part in an enzyme is known as apoenzyme, and the non-protein part, which is called the cofactor, is of 3 types. Now what are these 3 types? One is called prosthetic group, another one is called as your coenzyme, and another one is called as your metal ions. Okay, so these are the 3 things which is associated with that of the protein part of the enzyme to achieve its active site, so that now it can perform its function. So the first one, that is that of your prosthetic group, is the organic compound which is associated with that of the protein part in a tightly bound manner. Okay, so when it is tightly associated with that of the protein part, then only the active site becomes functional, and as a result of it, the functioning of the enzyme is successful. Okay, sometimes the organic part, which is the non-protein part, is associated with the protein part in a loosely bound manner. They are not so tightly bound manner, and only during the time of the functioning of the catalysis, they come and catalysis of the reaction, they come and bind with that, and then only the functioning of the enzyme takes place. And after that, again the binding may be they can just shed off from each other. Okay, like for example that of your NAD. This is a coenzyme. Okay, you might have heard about acetyl CoA. So these are the coenzymes. So coenzymes are also organic compounds. Prosthetic group are also organic compounds. But what is the fundamental difference? Prosthetic groups are tightly bound with that of the protein part of the enzyme, whereas that is your coenzyme is not so tightly bound. It is loosely bound with that of the enzyme part. And the last part is the last thing which has been discussed under this cofactor is the metal ion. Metal ion, say for example zinc, is associated with that of a proteolytic enzyme, that is carboxypeptidase. Once it gets associated with this enzyme, then only the enzyme becomes active, and as a result the functioning takes place easily. So cofactors are very important in the sense, until and unless these are associated with the protein part either loosely or tightly or in the form of metal ion, the functioning of the enzyme as a whole cannot take place. So this is about the chapter's enzyme portion, which is at the end of your biomolecules. Please go through the things given in your book of NCERT as well as this video to understand the topics well. That's all for today's class.